In this section, you learn the fundamentals of supervised learning for threat detection, where algorithms are trained on labeled data to identify and mitigate known threats. Key concepts included feature selection, model training, and the importance of quality datasets. Transitioning to unsupervised learning for anomaly detection, you explored how to detect unknown threats by identifying patterns and deviations in data without predefined labels. Techniques like clustering and dimensionality reduction were highlighted as crucial for uncovering anomalies. Building on these foundational methods, semi-supervised learning in cyber defense was introduced, combining labeled and unlabeled data to leverage large datasets with minimal manual labeling effort. This hybrid approach enhances threat detection capabilities by improving model accuracy and robustness. The importance of maintaining a balance between the two types of data was emphasized. Next, you delved into adversarial machine learning, focusing on the vulnerabilities of machine learning models to adversarial attacks. You learned about different attack vectors and defense mechanisms, underlining the necessity of designing resilient models that can withstand malicious attempts to deceive them. Finally, model evaluation and validation were covered, where you understood the critical steps in assessing the performance of machine learning models. Emphasis was placed on metrics like precision, recall, F1 score, and the significance of cross-validation techniques to ensure models generalize well to unseen data. Collectively, these lessons equipped you with a comprehensive understanding of machine learning applications in cyber defense, highlighting the strengths and limitations of each approach. The knowledge and skills gained will enable you to implement and evaluate robust machine learning solutions tailored to evolving cybersecurity challenges.